Hello everyone, this is an overview for Chapter 5 SP025 and let's start. There will be a series of videos explaining induced EMF with various changing situations. The first video after this, I'm going to explain to you how EMF is induced when straight while you're moving through magnetic field. And if you look at the green arrow here, you can use right hand rule to determine the direction of the induced current. And for this situation, velocity goes to the right, magnetic field goes out of page, hence the current goes downwards. So basically Chapter 5 is all about induced EMF, but by changing one variable at a time. So the next variable we can change to induce EMF is by changing the magnetic field, dB over dt. In this picture, the top figure has an intense magnetic field represented with blue X. The bottom figure has less magnetic field, hence the formula is negative NE dB over dt. Another way to induce EMF is by changing the area, dA over dt. The top figure, the coil has an area A, but when stretched, the new area is reduced. This changing of area in magnetic field will induce current, or EMF. Hence, the formula is EMF equals negative NB dA over dt. The fourth variable that we can change to induce EMF is by changing the theta. In the figure, the rotating coil is placed in a uniform magnetic field. This rotation will induce EMF. The given formula is EMF equals to NBA omega sine omega t. No need for negative sign. The last part in Chapter 5 is self-induction and mutual induction. For self-induction L, EMF is induced when the current in the coil is changed, hence di over dt. This process happens in split second. The induced EMF is also called back EMF. The equation is EMF equals to negative L di over dt. Value of L depends on the shape of your inductor. If it is solenoid, then L equals to mu naught n squared A over L. If it is coil, then L equals to mu naught n squared A over 2R. Self-induction occurs in electronic component called inductor. Inductor controls current flow and they store energy in its magnetic field. The energy U equals to half Li squared. And the last part is mutual induction. When two coils put closer to each other, EMF will start to be induced. The condition is like this. Coil 1 has constantly changing current. Normally, we're going to use AC because alternating current keep on changing its direction. This current flow will produce magnetic field, similar to a magnet bar. The change in the magnetic field of coil 1 will induce EMF in coil 2. The formula for this induced EMF is given by EMF equals to negative M di over dt, where M itself is M equals to mu naught N1 and 2 A over L. That's all for the overview of Chapter 5. In the next videos, we're going to discuss one by one the variables that cause induced EMF. Be sure to check it out.